We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
Astronomers have just captured stunning live images of an interstellar object racing through our solar system, only the third of its kind ever seen from Earth. Using Chile's Gemini South telescope, they expected to confirm a fading comet.
The size of it, that is 1,000,000 times more massive than the previous interstellar objects we've seen, and that's quite unlikely. There is not enough material in interstellar space.
Instead, they witnessed something extraordinary. Its tail, once a hazy plume, had transformed into a sharp, glowing spear, stretching with precision and growing stronger. And here's the chilling part. It's now heading straight toward a close encounter with Mars.
Right now, it's inside the orbit of Jupiter and is headed for its closest pass to the Sun at the end of October. That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
NASA's latest findings. Astronomers recently observed something unexpected in the skies. At the end of August, when Chile's Gemini South telescope was aimed at the interstellar comet 3I/ATLAS, scientists expected to confirm the usual behavior, dust and ice slowly releasing as it moved toward the Sun.
Even closer to the Sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the Sun.
Instead, what they saw raised serious questions. The comet's tail had transformed. Originally a faint plume, it had stretched into a sharp, luminous spear. It was glowing more intensely and extending farther than before. Official reports described it as significantly more extended, but that phrasing hides the real impact. This was not a random, chaotic tail. It was growing with precision, almost as if under some form of control. Now, let's pause here. Think about every comet you've seen in pictures. Messy, scattered, unpredictable. Their tails form when heat from the Sun causes frozen gases in the nucleus to sublimate, releasing jets of vapor and dust. These streams are usually chaotic, bent, and twisted by changing solar winds. But 3I/ATLAS looks different. Its tail is broad, clean, and sharply defined. Instead of small jets puffing randomly, the tail stretched outward like a controlled exhaust stream, growing step by step. For a comet that originated outside our solar system, this was far from ordinary.
Right now, it's inside the orbit of Jupiter and is headed for its closest pass to the Sun at the end of October. That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
And that leads to the question, what exactly is happening here? Adding to the mystery, new photographs taken during the recent blood moon total lunar eclipse revealed that 3I/ATLAS may be turning green as it approaches the Sun. Normally, green coloration comes from diatomic carbon C, two molecules fluorescing in sunlight. But the intensity and timing of this shift suggest unusual chemistry, or something more complex. Now, let's bring you into this. If you were expecting a comet to behave chaotically, what would you think after seeing one behave with such precision? Do you believe this is simply a natural but rare phenomenon? Or could it point to processes we don't yet understand? For perspective, this is only the third confirmed interstellar object observed passing through our solar system. The first was Oumuamua in 2017, which also displayed strange behavior, including non-gravitational acceleration. The second, Borisov in 2019, behaved more like a traditional comet. But now, with 3I/ATLAS, we are seeing something even stranger. Its tail doesn't just look different. It seems to be evolving in an orderly, directed way. As 3I/ATLAS moves closer to the Sun, astronomers will continue tracking its transformation. The third interstellar visitor. An object from beyond our solar system is now moving at a speed of about 38 miles per second, or 38 miles per second, heading straight toward the Sun.
So far, they've discovered that this mysterious visitor is moving at an incredible speed of 61 kilometers per second relative to the Sun.
This object, named 3 Eyes I/Atlas, is only the third interstellar object ever detected, following the discovery of Oumuamua in 2017 and 2 I/Borisov in 2019. It was first identified in July through the Asteroid Terrestrial Impact Last Alert System, which explains its name. The designation 3I stands for the third interstellar object, while I marks its interstellar origin. Soon after its discovery, the Hubble Space Telescope captured images of Atlas, sparking worldwide scientific interest. For astronomers, this was a rare chance to analyze its size, composition, and activity.
All there is to know about NASA's latest observations of Comet 3I Atlas.
According to Dr. Rebecca Allen, co-director of Swinburne's Space Technology and Industry Institute, we've never had an object like this to study before. Dr. Laura Dreesen, a radio astronomer at the University of Sydney, confirmed that its trajectory proves it came from outside our solar system. On August 27th, astronomers using the Gemini South telescope in Chile obtained the first detailed images. These revealed a developing coma, a faint halo of dust and gas, along with the early signs of a tail, both classic markers of cometary activity. This was unusual because Atlas had not yet reached the Sun's inner regions, where comets typically become active. Its coma indicated that volatile ices on its surface were already sublimating, turning directly from solid to gas.
As insolation ramps up, volatile ices sublimate faster, dragging dust off the surface to form a brighter, broader coma and tail.
While not unprecedented, this early activity is uncommon and quickly drew global attention. At this stage, Atlas appeared to behave like a natural comet, activated by sunlight. However, some scientists noted irregularities in brightness and activity, sparking speculative theories about its true nature. These ideas remain outside mainstream consensus, but they highlight how little we know about such interstellar visitors. By late August, data showed Atlas developing a rapidly growing tail made of dust and gas, pushed away by solar radiation. What stood out was its unusual structure. According to the National Science Foundation's NOIR lab, the tail looked wider, cleaner, and more extended than typically seen in comets. Most comet tails appear fragmented or bent by variable solar winds, yet Atlas's tail appeared smooth and well-defined. Further analysis using the James Webb Space Telescope confirmed that Atlas contains unusually high levels of carbon dioxide, which may explain the unique tail formation. This discovery has given researchers valuable insight into the chemistry of materials formed in other star systems. A tail unlike any other. Comet tails usually form in two parts, a faint, dusty tail and a more directed ion tail. Both appear as hazy, flowing structures stretched by solar radiation and the solar wind. But recent images of 3 I/ATLAS show something different, a single, sharper, and more defined tail.
The 3I, marking it as the third interstellar object ever discovered.
What makes this unusual is its composition. Unlike typical comets dominated by water ice, 3 I/ATLAS contains a high concentration of carbon dioxide. Carbon dioxide sublimates at lower temperatures than water, which means the comet became active earlier than expected as it approached the Sun. This has raised scientific interest because the tail does not resemble what we normally see. Some independent theorists, though not affiliated with any official scientific bodies, have speculated whether the structure could indicate a directional process, perhaps even resembling propulsion. But let's be clear, no peer-reviewed research confirms controlled movement or artificial activity. Mainstream scientists emphasize that comet tails can vary significantly.
The good news for science is that now the tail is out, we can study the comet in far richer detail.
Especially with interstellar objects, whose chemical makeup is still poorly understood. Factors like solar wind behavior Atmospheric chemistry and the geometry of the comet's nucleus all play a role in shaping its tail. So what you're seeing with 3I/ATLAS may not be artificial. It may be a natural byproduct of its unique conditions. Still, this comet offers an opportunity to study how interstellar objects behave under the sun's influence. And here's a question for you. If scientists discover more comets with sharp tails like this, would it change how we classify interstellar objects? As 3I/ATLAS continued its inward journey, attention shifted to its trajectory. Normally, when comets outgas, jets of gas and dust escaping the nucleus cause micro-adjustments in orbit. These can slightly alter direction or spin, depending on the comet's rotation, surface irregularities, and composition. But with 3I/ATLAS, something different happened. Its trajectory remained surprisingly stable. Despite active sublimation and a growing tail, the orbit stayed clean and consistent. How could that be? One explanation is size and mass. Updated estimates suggest 3I/ATLAS may have a nucleus diameter exceeding 6.8 miles. A larger, denser body would be less affected by outgassing forces. In addition, its carbon dioxide-rich sublimation may create sustained, evenly distributed activity, which could explain the stable path. The CO2 plume mystery. Scientists have captured new data on interstellar object 3I/ATLAS, a rare visitor from beyond our solar system. Unlike ordinary comets, 3I/ATLAS displays unusual behavior as it approaches the Sun.
Suggests that the interstellar object may be developing a striking green tint. Astronomers think the shift could be tied to the comet's growing closeness to the Sun.
The object is producing a massive carbon dioxide plume, a coma of gas and dust dominated by carbon dioxide. This plume continues to expand as solar heat triggers the release of more ice and dust. Measurements suggest 3I/ATLAS has a diameter possibly exceeding 6.8 miles. Its early carbon dioxide-rich sublimation produces strong and sustained activity in a remarkably uniform pattern. The stability of its tail caught attention not only from mainstream scientists, but also from speculative theorists. Some suggested that the straight-line tail and lack of major orbital deviation might resemble intentional movement. However, no peer-reviewed studies support this idea. Theories of artificial control remain unverified. Harvard astronomer Dr. Avi Loeb, known for discussing interstellar objects such as Oumuamua, noted that the symmetry and trajectory of 3I/ATLAS are interesting.
Harvard professor Avi Loeb says aspects of these images, instead he argues, it could be alien technology.
Still, he has not claimed it is artificial. Importantly, no scientific institution has endorsed any theory of controlled propulsion. What makes 3I/ATLAS worth watching is the actual data. Its activity and stability are real and measurable. As the object entered the inner solar system, the James Webb Space Telescope added new observations. Infrared imaging revealed that the carbon dioxide plume extended approximately 217,000 miles, nearly the distance from Earth to the Moon. For comparison, most comets release a mixture of water vapor, carbon monoxide, and carbon dioxide. Here, the ratio is striking. Early analysis suggests a carbon dioxide to water ice ratio of about 8:1, one of the highest ever recorded in a comet. Carbon dioxide sublimates more easily than water ice, releasing gas at greater distances from the Sun. This explains why 3I/ATLAS developed an active coma and tail earlier than most comets we see in our solar system. Carbon dioxide jets also create smoother outflows, which could account for the uniform structure of its tail. Yet even with this explanation, the sheer size of the plume remains surprising. Models predicted the plume should collapse or dissipate under solar wind pressure at a smaller scale. Instead, it expanded far beyond expectations while maintaining structure. Some speculative voices have proposed unknown mechanisms or deliberate emission to explain the stability, but again, no published scientific data support artificial modulation. The nickel coating. One of the most debated ideas about 3I/ATLAS is the nickel theory, the possibility that its unusual brightness could be linked to metallic elements on its surface. When astronomers studied the comet's light signature, they noticed its reflectivity was far higher than expected for an object made mostly of rock and volatile ice. Instead of appearing dark and uneven, like many comets, 3I/ATLAS reflected sunlight with remarkable consistency.
3I Atlas gets closer to the sun, it will be illuminated, it will get brighter since it will reflect more sunlight.
To investigate, scientists analyzed its spectral signature, the breakdown of light bouncing off its surface. Some early readings suggested that metallic elements, including nickel, might be influencing its brightness. But here's the key detail. No peer-reviewed paper has confirmed this yet. The idea remains speculative. While fringe discussions have even suggested engineered alloys or industrial-grade materials, such claims are not recognized by NASA, ESA, or any official research body. Still, the reflectivity of 3I/ATLAS cannot be ignored. Natural nickel is not unheard of in space. It occurs in meteorites, asteroids, and cosmic dust. So, is it possible that this interstellar visitor carries trace metals from its home star system? Yes. And if true, it could reveal valuable insights about conditions in distant planetary systems. Now think about this. If nickel or other metals are present, how might they affect the comet's behavior as it sublimates, when heat from the sun causes its ice to vaporize? Could metallic traces alter its thermal balance or optical properties? These are the types of questions researchers are now modeling. Some scientists interested in technosignatures, possible evidence of artificial processes in space, have speculated about engineered surfaces. Astrophysicist Avi Loeb, known for his work on Oumuamua, has encouraged the community to remain open to unconventional interpretations when faced with anomalies.
Oumuamua is probably a comet. The only problem is there wasn't any cometary tail.
However, he has not claimed that 3I/ATLAS is artificial, and no scientific team has published evidence of anything beyond natural origins. Other explanations remain more likely. Surface crystallization could boost reflectivity. A smooth, uniform ice layer might reflect sunlight evenly, or the brightness could simply result from the angle at which telescopes captured sunlight bouncing off the comet. These scenarios are actively being studied with both ground-based and space observatories. If metals like nickel are eventually confirmed, even in small amounts, the discovery would be significant. It would offer a window into the chemical makeup of another planetary system, showing how materials like rock, ice, and metals combine beyond our solar neighborhood. At the center of the mystery remains 3I/ATLAS's nucleus, a dense core of rock and ice driving its bright coma and long tail. Yet its true size and composition are still unknown. The interstellar comet on a perfect aim. The interstellar comet 3I/ATLAS is on a rare and remarkable journey through our solar system. Astronomers call its path locked orbit and perfect aim, not because it is locked to the sun, but because its trajectory gives scientists a clear opportunity to study it in detail. In October 2025, 3I/ATLAS will make its closest approach to Mars.
So on October 3rd, 3I Atlas will pass within 29 million kilometers from Mars,
coming within about 18.5 million miles of the planet. That distance may sound vast, but for space observations, it places the comet within perfect range for telescopes around the world. Let's put its speed into perspective. 3I/ATLAS is traveling at more than 124,000 miles per hour. At that pace, it can cover the distance from Earth to the Moon in less than 2 hours. Unlike comets bound to our sun, this one is on a hyperbolic orbit. That means it isn't gravitationally tied to the sun at all. Instead, it will sweep through the inner solar system, pass between Mars and Earth's orbit, make a close approach to the sun, and then shoot back out into interstellar space, never to return. Now, how close will it get? NASA reports the comet will pass within 167 million miles of Earth, a safe distance, so there's no threat. Its closest approach to the sun is expected between October and December 2025, when it will come within about 130 million miles. After that, it will continue outward, beyond the orbit of Jupiter, and eventually leave our solar system altogether. What makes 3I/ATLAS special is its interstellar origin. Unlike comets such as Halley's Comet, which loop around the sun every few decades, 3I/ATLAS came from outside our solar system. That makes it only the third confirmed interstellar object ever detected, after 1I/Oumuamua in 2017 and 2I/Borisov in 2019.
It's a million times more massive than the previous two interstellar objects, Oumuamua and Borisov.
Each of these objects has challenged our understanding of cosmic visitors. But here's where it gets even more intriguing. Some scientists, like astrophysicist Avi Loeb, suggest unusual possibilities. Loeb has speculated before that 1I/Oumuamua might have been an alien craft. With 3I/ATLAS, he points to oddities in its path, such as passing unusually close to Venus, Mars, and Jupiter. While most astronomers dismiss the alien idea, these unusual alignments spark debate and make this comet even more fascinating to study. So, what does this mean for us? For scientists, it's a once-in-a-generation chance to observe material from another star system. For you, it's a front-row seat to watch a high-speed traveler that will never return. Atlas Hidden Probes. Harvard professor Avi Loeb has suggested that the interstellar object 3I/ATLAS might be more than just a comet. He proposed that its unusual stability and brightness could point toward a technological origin.
Harvard professor Avi Loeb says aspects of these images, including the brightness around the object and its unusual trajectory, suggests it's not natural.
Possibly capable of releasing hidden probes. But here's the fact. NASA and the European Space Agency officially classify 3I/ATLAS as a comet. No evidence exists that it carries anything artificial, and most scientists firmly dismiss that claim. So, let's focus on what we actually know. Normally, comets heat up as they approach the sun. This causes gas to vent from the nucleus, creating pressure that can make the body wobble or drift slightly. Large comets with uneven surfaces often show this instability. But 3I/ATLAS isn't behaving that way. Despite measurable outgassing, its orbit has remained precisely stable. No tumbling, no spin-induced deviations, just steady motion. Why? One explanation is that the nucleus might be more symmetrical than typical comets, balancing out the forces. Another theory is that gas jets are venting evenly from multiple points, preventing any wobble. A third possibility is density. If the object is more compact than estimated, the effects of venting would be weaker. Now, some outside the mainstream speculate that this stability could suggest an engineered structure, possibly reinforced. But again, no observational data support that. What astronomers can confirm is simple. 3I/ATLAS is behaving differently than expected, and that makes it scientifically valuable. Here's where things get even more interesting. On October 3rd, 2025, 3I/ATLAS will make its closest approach to Mars, passing at a distance of about 18 million miles. To put that in perspective, that's very close in astronomical terms. Its minimum orbit intersection distance, the gap between its path and Mars's orbit, is only 1.68 million miles. For an interstellar comet, that kind of alignment is extremely rare.
That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
This unique trajectory means spacecraft orbiting Mars will get a front-row seat. NASA's Mars Reconnaissance Orbiter will track it using its high-rise camera, which captures details at 61 feet per pixel. These images will help reveal the nucleus, coma, and gas release patterns with unprecedented clarity. For planetary scientists, this is a once-in-a-lifetime chance. It's the first time we'll observe an interstellar object so close to a planet. Every measurement counts, because if anything deviates from predictions, we'll have brand new data to analyze. Until then, 3I/ATLAS races forward, fast, silent, and on a path closer to Mars than any interstellar object we've ever recorded. NASA, JWST, and military eyes on ATLAS.
All there is to know about NASA's latest observations of Comet 3I Atlas.
Planned observations of 3I/ATLAS involve some of the most advanced instruments we have: NASA's James Webb Space Telescope, the Mars Reconnaissance Orbiter, and Juno. There are also whispers of classified monitoring, hinting that interest extends beyond civilian science. The main question driving speculation is this: could the comet's dense and bright tail be hiding something? The dust and gas scatter light so effectively that anything smaller than roughly 330 feet would be invisible to Earth-based telescopes if it were traveling inside or just ahead of the coma. So, what does that mean for us watching from the ground? In simple terms, even if smaller fragments or probes existed, we wouldn't see them. Now, here's where the theory builds. Some researchers ask whether the tail's structure could be creating an optical blind spot, or whether the outgassing, gas venting from the nucleus, could be masking subtle movements inside. These are not claims of artificiality. They are open technical questions. Missions like HiRISE aim to close these observational gaps by imaging, spectrography, and modeling. But a parallel, more controversial idea exists outside peer-reviewed science. It suggests that smaller objects, possibly even artificial, could be riding inside or ahead of the tail. Again, let's be clear. NASA, ESA, and other institutions have never endorsed this. There is no evidence to support it. The entire notion comes from the physics of how comet tails scatter light and hide details. Here's an example theorists have modeled. If an object detached from Atlas tens of millions of miles in advance and changed its speed by only 20 to 30 feet per second, it could, in theory, intercept Mars at the same time as the main body. That kind of precision is possible in human space missions, so the idea isn't physically impossible. But science needs data, not speculation. So far, no instruments have recorded any deviation from Atlas behaving as a single comet. Its trajectory has been stable, and no anomalies have appeared around the nucleus. Still, the debate reveals something bigger. Our current observational tools have limits. Dust, solar glare, and viewing angles can hide details from us. That's why spacecraft like Juno and the Mars Reconnaissance Orbiter are critical. They give us vantage points Earth cannot. Recently, the discussion about 3I/ATLAS moved beyond science circles. Congresswoman Anna Paulina Luna, a member of the U.S. House Committee on Science, Space, and Technology, publicly urged NASA to monitor the comet closely as it nears Mars.
Congresswoman Luna's visionary letter to NASA, exploring 3I Atlas.
In her statement and a podcast with astrophysicist Avi Loeb, she emphasized transparency about what we know and what we don't. Natural wonder or alien machine. The interstellar comet 3I/ATLAS has drawn global attention, with some headlines calling it an alien probe. But scientists agree it is a natural, though unusual, object. It's apparent that growth comes from normal cometary activity. As it nears the sun, solar heating causes it to release gas and dust, forming a coma and a tail. NASA has not entertained speculative claims, choosing instead to focus on data. Upcoming imaging and spectroscopic results from different missions are expected to clarify many of the mysteries surrounding ATLAS. A critical timeline is now set. On October 29, 2025, Atlas will reach its perihelion, the closest point to the Sun. The next day, October 30th, it will pass by Mars. This will give humanity its first close look at an interstellar object interacting directly with a planetary environment. What we observe in this narrow window could reshape our understanding of not just ATLAS, but the entire category of interstellar visitors. Once Atlas moves behind the Sun from Earth's perspective, solar glare will block ground-based tracking. During this blackout, NASA's Mars Reconnaissance Orbiter and its HiRISE camera will capture images at closest approach. Scientists aim to separate the comet's nucleus from its surrounding coma and measure how solar heating changes its activity. A key variable is trajectory stability. Comets usually experience small shifts due to uneven gas release. Yet Atlas has shown remarkable precision, with no deviation from predictions. This has fueled speculation. Fringe theorists argue that if ATLAS were to suddenly shift course by 20 to 30 feet per second, it could signal propulsion. However, no evidence supports this. If any unexplained deviation occurs, it would more likely challenge existing comet models rather than confirm artificial control. The most likely outcome is that ATLAS will continue on its outbound path, dimming with distance. Still, scientists remain cautious and prepared for surprises. When HiRISE captures new images, possibly on October 3rd, they may reveal the nucleus clearly for the first time. Observations could show whether it is symmetrical, fragmented, or unusually structured. Unanswered questions remain. Why is ATLAS's trajectory so stable despite continuous outgassing? Why is its carbon dioxide to water ratio unusually high? Why did it become active so far from the Sun? And why does its tail maintain such a clean, extended shape? These puzzles point not to artificial design, but to gaps in cometary models. Atlas may reflect chemistry shaped by a star system very different from our own. For now, Atlas is best understood as a rare sample from beyond our solar system, a chance to learn, not to speculate. Its upcoming encounters may provide answers that redefine how we view interstellar visitors. We hope you guys enjoyed this video. Stay tuned for more amazing stories.